So we have seen the insertion at different positions. If the user give different positions, what will be the logic we have seen. Now suppose if the user want to insert at the beginning, we will just ask the user to enter the new element which user want to insert. So beginning means what? So we know that the indexing starts from 0 to n minus 1. So therefore at 0 index, what is the position? We are considering position to be 1. So position is 1 to n actually. So at 0th index the position is 1. So if the user want to insert at the beginning of the array, that is at the position 1. So what modification we should be doing to the previous code which we have seen? We have seen the coding wherein earlier we was asking the user to enter the position, and depending upon that position we was doing the shift onto the right side, then we inserted the element. So what modification will be done to that piece of code? This is the same code which we have seen to insert a new element at different positions, so that I will be modifying. So first of all, in that case we will be not asking the user to enter the position. The indexing starts from 0 to n minus 1, but at 0th index we are considering position to be 1. So therefore we know that the position is 1. That is, we have to insert at the beginning. So we will not ask the user for that, and this else is not required. Directly we will ask the user to enter the new element. So that we will be asking the user enter new element. So if the user give the new element as 10, so if user give this value 10, we will accept actually scanf. We will take that 10 actually and we'll store at the address of val. Then what modification is required in this for loop? Now since we know that we will be inserting at position 1, so therefore since this loop was starting from where it was, we know that we have to do shifts from n to the position. Now this thing will be the same, that is starting point I is equal to int I is equal to size minus 1. So we will start from the last actually, that is okay, till when we have to do these shifts. So instead of this position actually, we know that we have to insert at the beginning of the array, that is at the position 1. So at position 1 the indexing is at the 0. So we can simply write actually in this case like this, I or I greater or equal to 0. This condition I should be greater or equal to 0, that is from n to this 0th index we want these operation to be performed by this greater or equal to 0, because we know that we have to do these shifts actually till we reach at the index 0. Therefore it should be greater or equal to 0, and decrementation because we are starting from n to the 0 actually, we are moving from vice versa from n to beginning. Therefore we have to decrement, and the same thing, that is a of I plus 1 a of is equal to a of I, this will be remaining as it is. Then after we reach here, now we have to insert a new element. So what changes we can do here? Since we are not asking user to enter the position, we will simply write a of 0 is equal to the new element, that is val. So this is a of 0, that because we are inserting the new element here. So like this, and size plus plus. So this is a modification when the user want to insert the new element at the beginning. We will not ask the position. We know beginning means the index will be 0 or and position is 1. We know that. If you have to insert at the end directly, you will be simply writing a of size is equal to val. No shiftings, no for loop, nothing is required. You can see what is the time complexity we have seen here. So depending upon, if we have seen if it was here actually, that is in the earlier scenario if the position was 3, you have seen that we have to do how much shifts actually we have to do total if the size is n number of elements, so n minus position. So depending upon the position we have to do that much shift. We have to shift all those elements that much amount of time. If it was at the end, we have seen actually no shifts are required. So if we have to insert at end, in that case, what is the time complexity at the end? We don't have to do the shifts, therefore time complexity is O of 1, and therefore this is the best case actually, wherein no time is required. But at the beginning actually, whenever we have to insert at the beginning, how much shifts are required? We have to shift all the elements, therefore O of n. So that is a worst case. And if it is a different position, so at different positions, what will be the time complexity? It will be O minus n minus position. This much time. If the position is 2, so number of elements minus position, that much shifts are required. So in the case actually, whenever you are asked in exam, you will always give the best case actually, that is O of 1. Now in case of the unsorted array, we know unsorted array in which they are not arranged in the order. The order is not important in case of the unsorted array. So in this case actually, we have seen in general in the array how to perform the insertion at the beginning, at the end, at the different positions. And this is an unsorted array. So also we can do one thing actually, since we know that in the array, whenever we have to insert at the position, we have to shift all the elements. So if it is an unsorted array in which the ordering is not important, so what other logic you can apply? So since we have seen, if we have to insert actually the element at the position, we have to shift all the elements. Instead of doing that actually, if it is an unsorted array, then what best case we can try in that case. In case of the sorted array, I will talk later, but just to talk about if the array is unsorted, in which the ordering is not important, and if we have to insert say 10 actually at position equal to 3. So we have first of all seen now how to insert at the middle, at different position, at beginning, at the end. Now instead of inserting actually at different position, that is using this for loop, instead of that, if it is an unsorted array, what different thing you can do is that instead of shifting all these elements onto the right side, you can simply, what you can do at this position 3, whatever value is present, here we are having 3, simply store this 3 actually at the end of the array. So if you store this 3 at the end of the array, that means you are maintaining this value actually in your array, you are not losing the data. And then you can simply insert the new value actually at this position. That means you are doing the swapping, you are not doing the shifting. So this I am saying only if it is an unsorted array in which the ordering of the elements is not important. If it is a sorted array, we know that the ordering is so much important. That is, it should be ordered in the sequence order. So the ordering matters. In that case, the ordering will get disturbed if you do the swapping. In that case, and you have to do these shifts, you have to maintain the order. You have to not disturb the order. But if it is an unsorted array and if they are giving you the position actually as different position, and they are saying to insert the element, so instead of doing all these shifts actually, the best code is in that case use unsorted array, and at position simply what you can do, the logic is that you will do the swapping, that is the element which is present at that position. So therefore A of equal to A of position minus 1. A of size is what? A of 7. A of position minus 1. So position minus 1, that is index will be 2. Therefore we are storing this 3 here. At 7 actually we are storing this 3 here, and then we can simply do A of position minus 1 is equal to well. This piece of code we can do. That means here what will happen? A of 2 is equal to 10. That means what order we will get here actually? In case of, if it is an unsorted array, 5, 2, then what we are doing actually, we are inserting 10 actually. So we are inserting 10 actually in the unsorted array here actually, that the same position, that is 3 and index is 2, and in that element which was present here we have shifted to the last index. So in that case, if it is an unsorted array, you don't have to do all these type of shiftings actually. So this is a best case. It is an unsorted array in which you are asked to insert the element at the position. But if it is a sorted array, you have to do these shifts are required actually. That is, you have to maintain the order. So you have to shift one by one. You cannot do the swapping as I have shown here. So these changes are required. And so I hope so you understood actually as I talked about the time complexity for the sorted array, for the unsorted array. So this is what actually we have seen till now, how to perform the insertion operation at different position for sorted and for unsorted array, and what time complexity is required, what is the best case, what is the worst case. And I hope so you understood these logics, these changes, what are required. Now we will be seeing the deletion operation in the array, and we will be seeing how to delete the element at the beginning, at the end, at the middle actually For the sorted array, for the unsorted array, what is also we will be seeing the time complexity. So we'll be writing the program and understanding in detail about these deletion operations. So let's meet in the next session for deletion operation. Till then, bye bye, take care.